December 7th, 1944. Major Wolfgang Schreiber's hands were steady as he lifted the olive drab case onto the examination table in the underground technical facility beneath Aachen. The American radio set had been captured 3 days earlier during a skirmish near the Hürtgen forest, taken from a dead sergeant whose body still lay frozen in the December mud. Around Schreiber, 4 of Germany's most experienced signals intelligence officers leaned closer, their breath forming small clouds in the unheated concrete room. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. For 2 years, Wehrmacht intelligence had insisted that American infantry communications were primitive, unreliable systems cobbled together by a nation that understood mass production but not sophisticated engineering. The reports from Army Group B headquarters described American radios as heavy, short-ranged equipment that frequently failed under combat conditions. Yet something contradicted these assessments. American infantry units coordinated with uncanny precision. Their artillery responded to forward observer calls within minutes. Their companies maintained contact with battalion headquarters across distances that should have been impossible for portable radios. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The radio before them was an SCR-300, the backpack set that American infantry had been using since the Normandy invasion 6 months earlier. Schreiber had requested this examination personally after reading field reports that made no sense. German company commanders used motorcycle couriers or field telephone lines to communicate with their battalions. American company commanders, according to intercepted messages, simply talked directly to their headquarters from anywhere on the battlefield. The mathematics of radio propagation suggested this should be impossible with portable equipment. Schreiber intended to discover how the Americans had accomplished it. What the German signals officers would discover over the next 72 hours would fundamentally alter their understanding of American technical capabilities and reveal an industrial sophistication that made Germany's defeat inevitable. The examination of this single radio would expose not merely better engineering, but an entirely different philosophy of warfare built on electronics that the Reich could never match. The capture had occurred on December 4th near Kleinhau, a village in the Hürtgen forest where American and German forces had been locked in brutal combat for weeks. Hauptmann Ernst Dietrich, commanding a company of the 27th Infantry Regiment, had led a night counterattack against American positions on Hill 232. The attack succeeded in overrunning an American rifle company, but at terrible cost. Dietrich's company suffered 40% casualties in the assault. Among the American dead was a radio operator, his SCR-300 still strapped to his back, the handset frozen to his lifeless hand. Dietrich, a signals officer before the war, recognized the radio's importance immediately. He had standing orders from divisional intelligence to secure any American radio equipment found intact. Most combat soldiers would have simply destroyed captured radios to prevent them from falling back into enemy hands, but Dietrich understood that technical intelligence could save German lives. He personally removed the radio from the dead sergeant, wrapped it carefully in a shelter half, and sent it to the rear with his next casualty evacuation. The radio reached Army Group B headquarters in Düren on December 5th. Colonel Heinrich Baumer, chief signals officer for the Army Group, examined it briefly and immediately ordered it transported to Technical Testing Station 17, the underground facility in Aachen, where Germany's best signals intelligence specialists analyzed captured Allied equipment. Major Wolfgang Schreiber received the radio on the afternoon of December 6th with orders to conduct a complete technical analysis within 72 hours. Field Marshal Model wanted answers about American communications capabilities before the planned Ardennes offensive began in less than 2 weeks. Schreiber had been analyzing Allied communications equipment since 1942. Before the war, he had worked as a design engineer for Telefunken, one of Germany's leading electronics manufacturers. He understood radio theory, circuit design, and manufacturing techniques at the highest level. With him for this examination were Oberleutnant Hans Kessler, a specialist in frequency control and crystal oscillators, Hauptmann Friedrich Weber, an expert in receiver design, and 2 technical sergeants who handled the actual testing equipment. They began with external examination on the morning of December 7th. The SCR-300 consisted of 2 main components. The radio set itself mounted in a canvas carrying case designed to be worn as a backpack, and a separate handset connected by a flexible cable. The entire assembly weighed approximately 35 pounds when loaded with batteries. Schreiber noted immediately that the construction was robust, designed for harsh field conditions. The radio case was metal, painted olive drab, with rubber gaskets protecting every seam and connector. The design philosophy was unmistakable. This was equipment built to survive the abuse of infantry combat. Weber examined the carrying harness and noted its sophisticated design. The weight was distributed across the shoulders and hips using padded straps with quick-release buckles. An American soldier could don the radio in seconds and shed it even faster if necessary. German portable. Radios typically used simple strap arrangements that concentrated weight on the shoulders and back. The American design demonstrated thought given to human factors and operator comfort. Kessler inspected the antenna system and found it surprisingly clever. The radio used a collapsible whip antenna that extended to approximately 6 feet when deployed, but collapsed to less than a foot for transport. The antenna mount included a spring base that allowed the antenna to bend without breaking, critical for soldiers moving through forests or buildings. The connector was standardized, presumably allowing replacement antennas to be swapped quickly in the field. German antennas were typically rigid rods that broke easily and could not be quickly replaced. When they opened the main radio case, the first surprise came. The interior was immaculately organized with every component clearly labeled and accessible. The circuit boards were mounted on a chassis that could be removed as a single assembly for maintenance. Every tube socket was numbered. Every connection point was marked. The design assumed that field maintenance would be performed not by skilled radio technicians, but by barely trained soldiers using simple tools and minimal technical knowledge. Schreiber found this deeply disturbing. German military radios required skilled technicians for maintenance and repair. Components were hand-wired. Connections were made using techniques that required training and experience, and repairs demanded technical knowledge that only signals specialists possessed. The Americans had designed their radio for mass production and field maintenance by semi-skilled personnel. This suggested a completely different approach to military logistics and maintenance. Weber began tracing the circuit design and immediately encountered the second shock. The radio used frequency modulation, FM, not the amplitude modulation, AM, that virtually all military radios employed. FM was theoretically superior, providing static-free communication and resistance to electrical interference, but it required significantly more complex circuitry and precise frequency control. German engineers had considered FM for military applications before the war, but rejected it as too expensive and complicated for field equipment. The decision to use FM suggested several things, none of them comforting. First, it meant American engineers had solved the technical problems of building reliable FM transmitters and receivers that could survive battlefield conditions. Second, it meant American factories had the precision manufacturing capability to produce FM circuits in quantity. Third, it meant American military planners valued communications reliability enough to accept the additional complexity and cost of FM technology. Kessler examined the frequency control system and discovered crystal oscillators, precisely cut quartz elements that determined the radio's operating frequency. The SCR-300 contained a crystal switching mechanism, allowing the operator to select between 6 preset channels simply by rotating a dial. Each channel was crystal controlled for absolute frequency stability. This was extraordinary. Crystal oscillators were expensive precision components requiring specialized manufacturing techniques. In Germany, crystal-controlled radios were limited to high-command units and aircraft where the cost could be justified. He carefully removed one crystal unit and examined it under magnification. The quartz element was flawlessly cut, the electrodes perfectly aligned, the entire assembly hermetically sealed in a metal holder. The frequency marking indicated precision to within a few kilohertz, accuracy that would require weeks of laboratory work using German manufacturing methods. Yet the Americans were installing 6 of these crystals in every infantry backpack radio and producing these radios by the thousands. The technical sergeants connected the radio to test equipment and applied power. The vacuum tubes glowed to life immediately. Weber monitored the warm-up time and noted it with approval, 30 seconds from power application to operational status. German portable radios typically required 3 to 5 minutes of warm-up time. The American radio used special quick heating tubes that sacrificed some longevity for rapid operational readiness. In combat, where seconds could mean life or death, this trade-off made perfect sense. They conducted transmission tests using the facility's antenna range and receiver equipment. The SCR-300 transmitted a clean FM signal with remarkable frequency stability. The automatic frequency control circuits maintained perfect tuning without manual adjustment. Weber, who had designed Wehrmacht radios, knew that German equipment required constant manual tuning to compensate for temperature changes, component drift, and power supply variations. American radios tuned themselves automatically. The receiver tests revealed even more sophisticated engineering. The SCR-300's receiver used a super-heterodyne circuit design with multiple stages of amplification and automatic gain control. The audio quality was extraordinary, clear voice reproduction with minimal distortion even at weak signal levels. German portable radios produced audio that was barely intelligible under good conditions and completely useless at long range. The American radio delivered clear communications that any soldier could understand even in poor signal conditions. Schreiber began drafting his preliminary report to Colonel Baumer. Each sentence contradicted years of intelligence assessments and propaganda claims. He wrote that the SCR-300 represented technical sophistication equal to or exceeding the best German laboratory equipment, yet it was clearly designed for mass production and field use by common infantry soldiers. The frequency modulation system provided communications clarity that amplitude modulation could never match. The crystal frequency control ensured reliable channel selection without manual tuning. The automatic gain control and automatic frequency control circuits eliminated the need for skilled operators. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now, back to the story. Most disturbing of all, every aspect of the radio's design indicated mass production on a scale Germany could not contemplate. The components were standardized and interchangeable. The construction used techniques that enabled rapid assembly by semi-skilled workers. The maintenance approach assumed field repairs by soldiers with minimal training. The Americans were building these sophisticated radios the way Germany built simple consumer products, through industrial processes that prioritized quantity and reliability over individual craftsmanship. Over the next 2 days, the examination team conducted exhaustive range tests, environmental tests, and component analyses. They tested the radio in cold conditions, simulating winter combat. They tested it in simulated rain and snow. They subjected it to vibration and shock equivalent to being dropped from vehicle height. The SCR-300 continued operating through all these tests. The construction quality was not merely adequate but exceptional. Every component was specified to military standards that exceeded anything in German practice. The range tests produced results that Schreiber initially refused to believe. Using the facility's antenna farm outside Aachen, they achieved reliable voice communications at distances exceeding 3 miles. Under optimal conditions with elevated antennas, the range extended to 5 miles. This was impossible, according to Wehrmacht communications doctrine. Portable infantry radios were expected to operate at ranges of perhaps 1 mile under good conditions. Company commanders were supposed to use field telephone lines or motorcycle couriers for longer-range communications. Yet American infantry companies were apparently maintaining direct radio contact with their battalion headquarters from anywhere on the battlefield. The SCR-300 made this possible through a combination of frequency modulation's superior propagation characteristics, high transmitter power output of approximately 4.5 watts, sensitive receiver design, and efficient antenna systems. German portable radios typically produced 1 watt or less of output power and used simple receiver circuits. The American radio outperformed German equipment by factors of 3 to 5 in operational range. Weber conducted detailed circuit analysis and discovered design sophistication that shocked him professionally. The transmitter used a frequency multiplier chain that generated the FM signal at a lower frequency, then multiplied it up to the operating frequency. This technique simplified the oscillator design while maintaining frequency stability. The receiver employed double conversion superheterodyne architecture with an intermediate frequency that optimized selectivity and sensitivity. These were advanced design concepts that German engineers understood theoretically but had not implemented in field equipment. The component quality analysis revealed manufacturing capabilities that seemed almost impossible. The vacuum tubes were specially designed ruggedized military types with reinforced filaments, shock-resistant mounting, and specifications that guaranteed long operational life under field conditions. The resistors and capacitors were military-grade components with tight tolerance and environmental specifications. The wire used in coils and transformers was precisely wound to specifications that would have required handwork in German factories, but appeared to have been machine-wound in American production facilities. Kessler examined the crystal switching mechanism and marveled at its mechanical engineering. A simple rotary switch allowed the operator to select between 6 preset channels. The switching action was positive and reliable, with each position clearly detented. The switch contacts were heavy-duty silver alloy designed for thousands of operations without degradation. The entire mechanism was sealed against moisture and contamination. This was precision mechanical engineering applied to a component that most designers would have treated as simple and crude. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The battery system revealed American thinking about logistics and field operations. The SCR-300 used standard BA-70 dry cell batteries, 6 of them providing approximately 10 hours of operating time with typical usage patterns. The batteries were commercial items, produced in massive quantities for civilian applications and adapted for military use. This was brilliant logistics planning. Rather than designing special military batteries that required dedicated production facilities, the Americans used civilian battery designs that could be manufactured by existing industrial infrastructure. German portable radios used specialized military batteries that were perpetually in short supply because they required dedicated production facilities that competed with other military priorities. American radios used batteries that millions of American factories could produce without disrupting military production. The economic implications were staggering. American industry could simultaneously produce civilian goods and military equipment using shared components and manufacturing processes. German industry had to choose between civilian and military production because the two used different components and different processes. Schreiber's final report to Colonel Baumer ran to 43 pages of technical analysis, circuit diagrams, component specifications, and strategic assessment. The technical section documented every aspect of the SCR-300's design, construction, and performance. The strategic section drew conclusions that Schreiber knew would be unwelcome at higher headquarters, but could not avoid stating clearly. He wrote that the SCR-300 demonstrated American industrial capacity to produce sophisticated electronic equipment in quantities that Germany could not match. The radio incorporated precision components, advanced circuits, and manufacturing techniques that required specialized factories, trained workers, and quality control systems that simply did not exist in the Reich on sufficient scale. More critically, the radio was clearly not a limited production item reserved for elite units. This was standard infantry equipment issued to regular line companies throughout the American Army. The implications were clear and devastating. If America could mass-produce sophisticated FM radios for common infantry use, they could mass-produce any electronic equipment needed for warfare. Their industrial base possessed capabilities that made the outcome of the war inevitable, regardless of tactical or operational successes Germany might achieve. You cannot defeat an enemy who can produce unlimited quantities of equipment superior to your best models, while simultaneously maintaining civilian production and supporting allied nations. Schreiber sent his report through channels on December 10th. Colonel Baumer read it that evening and immediately recognized its significance. He forwarded it to Army Group B headquarters with a cover letter strongly endorsing Schreiber's conclusions. Field Marshal Model read the report on December 11th, 4 days before the Ardennes offensive was scheduled to begin. According to post-war accounts from Model's staff officers, he finished reading, set the report aside, and said simply that the war was already lost and the offensive would change nothing. The report reached OKW, the Wehrmacht High Command, on December 13th. It was filed with hundreds of other technical intelligence reports that documented Allied equipment superiority in virtually every category of military materiel. No record exists of Hitler reading the report or being briefed on its contents. The Ardennes offensive began on schedule on December 16, 1944, achieving initial tactical surprise, but ultimately failing to change the war's strategic outcome. The SCR-300 radios that Wehrmacht technical intelligence examined in December 1944 represented just one example of a much larger pattern that German officers were observing across all theaters of the war. By late 1944, captured American equipment consistently demonstrated technical sophistication and manufacturing quality that exceeded German capabilities. Whether examining artillery fire control systems, tank optical equipment, aircraft instruments, or radio communications devices, German technical experts reached the same disturbing conclusion. America possessed not merely superior quantities of equipment, but fundamentally superior industrial processes. The SCR-300's development history, which German intelligence eventually pieced together from captured documents and interrogated prisoners, revealed how American industry approached military equipment designed differently than German manufacturers. The radio had been developed by Galvin Manufacturing Corporation, a commercial radio manufacturer in Chicago that Americans knew as Motorola. The company had designed the SCR-300 specifically to meet Army requirements for portable infantry communications, with range sufficient to connect company commanders with battalion headquarters. Development had begun in 1941, more than a year before America entered the war. The design team, led by engineer Daniel Noble, had chosen frequency modulation technology specifically because it provided superior performance in the electromagnetically noisy environment of modern mechanized warfare. They had selected components for reliability and manufacturability rather than minimal cost. They had designed circuits for ease of production rather than theoretical elegance. The entire development philosophy prioritized practical field performance over technical sophistication for its own sake. Galvin Manufacturing began producing SCR-300 radios in quantity in 1942. By 1944, production had reached thousands of units monthly. The radios equipped every American infantry battalion and many supporting units. Production continued throughout the war, with total manufacturing exceeding 50,000 units. This was mass production of sophisticated electronics on a scale that German industry had never attempted for military equipment. The comparison with German portable radio development was instructive and depressing. Germany's closest equivalent to the SCR-300 was the Torn Fu B1, a backpack radio that entered service in 1943. The Torn Fu B1 used amplitude modulation technology, produced less than 1 watt of transmitter power, achieved operational range of approximately 1 mile, required extensive manual tuning, and was manufactured in quantities measured in hundreds rather than thousands. German infantry battalions typically had 1 or 2 Torn Fu B1 radios, compared to the dozens of SCR-300 sets available to equivalent American units. Major Schreiber's examination of the SCR-300 included component sourcing analysis that revealed another dimension of American industrial advantage. The vacuum tubes used in the radio were manufactured by RCA Sylvania, and other American electronics companies to military specifications that guaranteed performance and reliability. These companies produced millions of tubes annually for military and civilian applications. The precision resistors came from specialty manufacturers who supplied both military and commercial markets. The capacitors, transformers, switches, and other components all came from established industrial suppliers with massive production capacity. Germany's electronics component industry was fragmented among small manufacturers who produced limited quantities to varying quality standards. There was no equivalent to American industry standardization that allowed components from different manufacturers to be freely interchanged. German radio manufacturers often had to design circuits around whatever components were available, rather than specifying optimal components and being confident of obtaining them in quantity. This fundamental difference in industrial organization meant that American radios could be designed for optimal performance, while German radios had to be designed for component availability. The crystal oscillators that so impressed Oberleutnant Kessler represented another area where American industrial capability exceeded German capacity. Precision quartz crystal manufacturing required specialized equipment, skilled technicians, and rigorous quality control. American companies like Bliley Electric and Reeves Hoffman produced millions of crystals annually to specifications measured in parts per million. These crystals went into military radios, commercial communications equipment, and electronic instruments. The manufacturing infrastructure existed on a scale that supported both military and civilian requirements simultaneously. German crystal manufacturing was concentrated in a few facilities that struggled to meet military requirements alone. Civilian applications had been largely suspended for the duration of the war. The crystals produced varied significantly in quality, with reject rates that would have been unacceptable in American production facilities. German radio designers used crystals sparingly, reserving them for applications where frequency stability was absolutely critical and accepting manual tuning for everything else. The technical testing station in Aachen continued examining American Teleistgome equipment throughout December and into January 1945. They received captured examples of the SCR-284 mobile radio, the SCR-536 handheld radio, various radar sets, and electronic test equipment. Every examination reinforced the same conclusions. American electronics manufacturing operated at a level of sophistication, scale, and quality that Germany could not match, and had no prospect of matching regardless of how long the war continued. Colonel Baumer compiled a summary report in January 1945 based on all the technical intelligence his office had gathered. He documented the systematic superiority of American electronics across every category of equipment. He noted that this superiority derived not from theoretical knowledge, where German scientists and engineers remained world leaders, but from manufacturing capability and industrial organization. He concluded that Germany's defeat was inevitable because modern warfare had become primarily an industrial competition that Germany had lost before the first shot was fired. The report circulated among senior Wehrmacht officers, but generated no substantive response. By January 1945, Germany was fighting for survival with Soviet forces advancing from the east and American and British forces advancing from the west. Strategic assessments about industrial capacity were irrelevant when the immediate question was whether the Reich would survive another month. The technical intelligence that might have influenced decisions in 1940 or 1941 was merely confirmation of obvious reality in 1945. Major Schreiber evacuated Aachen in February 1945 as American forces approached. He took his technical reports and moved east to Kassel, then to Leipzig as the front continued collapsing. In April 1945, he destroyed his classified documents to prevent capture and surrendered to American forces near Dresden. He spent 6 months in a prisoner of war camp before being released in October 1945. Post-war, Schreiber returned to the electronics industry, working first for Grundig and later for Telefunken. He never discussed his wartime technical intelligence work publicly, but did provide information to military historians researching Wehrmacht communications in the 1960s and 70s. He died in 1978 at age 64. His personal papers, donated to the Bundesarchiv in Koblenz, included copies of technical reports on American equipment that provided historians with detailed documentation of how German experts viewed Allied technological capabilities. The SCR-300 radio that Schreiber examined in December 1944 survived the war. After German forces evacuated Aachen, American troops discovered the technical testing station and recovered various captured Allied equipment, including the SCR-300. The radio was returned to American custody and eventually sent to the Signal Corps Museum at Fort Gordon, Georgia. It remains in the museum's collection today, one of tens of thousands of SCR-300 radios manufactured during the war, and one of the few with documented history of German technical examination. The broader story of American communications equipment in World War II demonstrates how industrial capacity determines military outcomes in modern warfare. The United States produced over 1 million military radio sets during the war across dozens of different types and models. Production included everything from simple handheld radios like the SCR-536 to sophisticated high-frequency sets, radar systems, and electronic countermeasures equipment. This massive production supported not only American forces but also British, Soviet, French, and other Allied militaries through Lend-Lease programs. German radio production during the same period totaled approximately 100,000 sets, 10% of American output. The sets produced were generally simpler, less capable, and less reliable than American equivalents. German forces chronically suffered from inadequate communications equipment, forcing commanders to rely on field telephone lines and motorcycle couriers for communications that American forces handled routinely by radio. The communications disadvantage contributed directly to tactical defeats and operational failures throughout the war. The SCR-300 exemplified American advantages in battlefield communications. It provided infantry companies with reliable contact to battalion headquarters across the entire depth of the tactical battlefield. This enabled responsive artillery support, rapid reinforcement of threatened positions, coordination of combined arms operations, and maintenance of command and control under the chaos of combat. German infantry companies lacked equivalent capabilities and consequently suffered higher casualties and achieved fewer tactical successes when operating at distances beyond field telephone range. American soldiers who used the SCR-300 inches combat universally praised its reliability and performance. After-action reports from infantry units in Europe and the Pacific consistently noted that radio communications contributed significantly to mission success. Artillery forward observers reported that the SCR-300 enabled them to direct fire missions from positions miles from their batteries, providing responsive fire support that saved infantry lives and broke up enemy attacks. Company commanders reported that maintaining radio contact with battalion headquarters reduced isolation and enabled rapid coordination when situations changed. The radio's impact extended beyond purely tactical communications. The SCR-300 enabled new operational concepts that would have been impossible with previous communications technology. Airborne operations, where units landed scattered across enemy territory, relied on SCR-300 radios to establish command and control after landing. Amphibious assaults used SCR-300 radios to coordinate ship-to-shore movement and establish communications networks ashore before field telephone lines could be laid. Special operations units behind enemy lines used SCR-300 radios to maintain contact with headquarters and call for air support or extraction. The strategic significance of the SCR-300 and similar American communications equipment lay not in any single battle or engagement, but in the cumulative advantage provided across thousands of tactical actions throughout war. Superior communications enabled American forces to coordinate more effectively, respond more rapidly to changing situations, concentrate forces more efficiently, and employ combined arms more successfully than opponents with inferior communications. These advantages translated directly into battlefield victories that accumulated into operational successes and ultimately strategic triumph. The German examination of captured SCR-300 radios in December 1944 came far too late to influence the war's outcome. Had similar examinations occurred in 1940 or 1941, when Germany still possessed options and could have adjusted industrial priorities and strategic planning, the intelligence might have proven valuable. By late 1944, the information merely confirmed what perceptive observers already understood. Germany had challenged an industrial power with 10 times its manufacturing capacity and infinitely greater access to raw materials. The outcome had never been in doubt. Once America fully mobilized its industrial base, the technical intelligence reports written by Major Schreiber and his colleagues document a moment of clarity when military professionals confronted reality unfiltered by propaganda or wishful thinking. The examination of American radio equipment forced German engineers to acknowledge that their nation's industrial capacity could not match American production in quantity or quality. This realization came too late to change anything, but early enough that the officers who understood it had to continue fighting a war they knew was lost. The story of Wehrmacht officers examining captured SCR-300 radios illustrates how modern warfare had evolved by the middle of the 20th century. Victory no longer belonged to the side with superior tactics, training, or courage. Though those factors remained important, victory belonged to the side with greater industrial capacity to produce weapons, equipment, and supplies in overwhelming quantities. The SCR-300, with its precision crystals, sophisticated circuits, and mass production in quantities of tens of thousands, symbolized American industrial dominance that proved decisive. Daniel Noble, the engineer who championed frequency modulation technology for the SCR-300 despite military preference for conventional amplitude modulation, never knew that German engineers would later examine his radio and recognize it as evidence of inevitable American victory. Noble continued working in electronics after the war, eventually becoming executive vice president at Motorola and contributing to mobile communications development. He died in 1994 at age 92, recognized as a pioneer in radio engineering and military communications. The SCR-300 remained in service with American forces through the Korean War before being replaced by improved transistorized radios in the late 1950s. Many Allied nations used SCR-300 radios for decades after World War II ended. The fundamental design principles that Noble and his team pioneered, frequency modulation for military communications, crystal frequency control for reliability, and design for mass production and field maintenance, became standard practice in military radio development worldwide. The technical intelligence that Major Schreiber compiled in his December 1944 examination of the SCR-300 eventually found its way into historical archives where military historians and technology researchers have studied it extensively. The reports provide unique insight into how professional military officers assess enemy capabilities and what they conclude when examining evidence that contradicts official narratives. Schreiber's methodical documentation of every aspect of American radio design, his careful analysis of manufacturing techniques, and his willingness to state uncomfortable strategic conclusions demonstrate intellectual honesty that transcends national loyalties. The lesson that Schreiber and his colleagues learned from examining American communications equipment remains relevant in the 21st century. Industrial capacity still determines military outcomes when conflicts extend beyond brief engagements. The side that can design, manufacture, and field superior equipment in greater quantities retains decisive advantages, regardless of temporary tactical setbacks. Technology continues advancing, but the fundamental principle that victory requires both technical excellence and industrial scale remains unchanged. Modern military communications equipment bears little physical resemblance to the SCR-300, with its vacuum tubes, crystal oscillators, and frequency modulation circuits. Contemporary radios use digital signal processing, software-defined architectures, and semiconductor electronics that would seem like science fiction to the engineers who designed World War II equipment. Yet the core requirements that the SCR-300 addressed, reliable voice communications across tactical distances, resistance to interference, ease of operation by soldiers with minimal training, and design for mass production remain fundamental to military radio development today. The story that began with German officers opening a captured American radio case in Aachen in December 1944 concluded with the complete transformation of how military forces communicate on battlefields. The examination revealed to perceptive observers that industrial warfare demands industrial capacity, that sophisticated technology means nothing without the manufacturing capability to produce it in quantity, and that victory ultimately belongs to the nation with superior industrial organization and production capability. The technical examination of the SCR-300 inches December 1944 represented merely one data point in a much larger pattern of technological assessment that German military intelligence had been conducting since 1942. The systematic evaluation of captured Allied equipment across all categories of military materiel had produced a comprehensive picture of comparative industrial capabilities that grew increasingly alarming as the war progressed. Each examination reinforced the same fundamental conclusion that American manufacturing had achieved a level of sophistication, scale, and efficiency that rendered German industrial capacity inadequate for sustained modern warfare. Major Schreiber's detailed analysis of the SCR-300 radio became part of a classified technical intelligence database maintained by the Wehrmacht High Command. This database contained thousands of reports documenting captured Allied weapons, vehicles, aircraft, electronics, and support equipment. Intelligence officers could cross-reference these reports to identify patterns and trends in enemy technological development. The patterns that emerged from this analysis painted a picture that senior German military leaders found deeply disturbing but could not effectively address given the Reich's deteriorating strategic situation. The radio communications category alone contained reports on dozens of different American radio types. Beyond the SCR-300 infantry radio, German technical teams had examined the SCR-284 vehicular radio set, which provided long-range communications for mobile headquarters units. They had studied the SCR-508 and SCR-528 series tank radios that enabled armored formations to coordinate across unprecedented distances. They had analyzed airborne radios, naval communications equipment, and specialized electronic warfare systems. Every examination revealed the same characteristics that Schreiber had documented in the SCR-300. Superior component quality, sophisticated circuit design, robust construction, and clear evidence of mass production on enormous scale. The comparative analysis was devastating. A typical American infantry battalion in 1944 possessed more radio communications equipment than an entire German division. American battalions had SCR-300 radios for company-to-battalion communications, SCR-536, handheld radios for platoon and squad coordination, and various specialized radios for artillery liaison, air support coordination, and other functions. German divisions relied primarily on field telephone lines, supplemented by a small number of radios concentrated at regimental and divisional levels. American forces could maintain communications while moving and maneuvering. German forces lost communications whenever they advanced beyond their telephone wire network. The intelligence database also documented captured American test equipment, maintenance tools, and technical manuals. These items revealed another dimension of American industrial sophistication that German analysts found remarkable. The Americans had developed comprehensive systems for training radio operators, maintaining equipment in the field, and repairing damaged radios using modular component replacement. German radio maintenance required skilled technicians with extensive training. American radio maintenance could be performed by soldiers who had received only basic technical instruction using standardized procedures documented in clear, illustrated manuals. The test equipment that accompanied American radio units demonstrated commitment to maintaining performance standards in field conditions. German technical teams discovered portable radio test sets that enabled unit-level technicians to verify transmitter frequency, measure output power, and check receiver sensitivity. These instruments were ruggedized for field use and designed for operation by personnel with modest technical training. German equivalents to such equipment existed only in specialized repair facilities far behind the front lines. American forces could verify radio performance at company level and replace defective units immediately from field stocks. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.